I have things that don't exist there, which is going to go, ooh, I don't think I'm happy with that. And if I hit run here, it's going to give me all kinds of DAC assistant errors, which tells me that it doesn't know where my DAC is at because I just plugged one in. And one of the things that you won't discover, but I have, is that when you change DACs, each DAC has a unique identifier, and so as it loads a second DAC up, it won't communicate with it because they're designed to work on, it's designed to where you have multiple ones on the same time, right? You can plug multiple USB ports in and they'll work, and you have to be able to separate between the two. So when I have one that's built for one DAC assistant, it won't work for another unless I go in and reconfigure it. Now, there's a couple of ways of reconfiguring it, and there is kind of a workaround that sometimes work, but the easiest way when you have this problem, which I happen to have all the time, is just to throw the old one away and start over again, right? You just go, okay, it's just a DAC assistant. Now, you don't have to do this because you don't have a new one, right? But I need another DAC assistant because mine is old.
Are we gonna do any labs where we use two?
I don't know, but I may mix them up with you guys just to make you mad at me, right? Okay, so it's probably Dev 3 is the only one that's here, okay? And I'm going to use channels 1 and 2. Okay, and I finish that. Plus and minus 10 volts, well, 0 to 10 volts probably, because it can't go anything from 0. And then we're going to do, of course, continuous samples. And I'm going to read 1,000 samples. And I'm going to do it at, what, 5 kHz or something like that? Like that. And I can go up here and run this and look at my numbers. Everybody's at 0 now, which makes me very nervous because it's not going to do anything when everybody's at 0. That's probably because I don't have somebody plugged in there, or I'm not getting any power out of this guy. Still 0, which is not a good sign. So why is it? Oh, it's probably 0 because I can't hook it up right. There we go. Now we have interesting signals there. Right, they're at least at some voltage, and when I heat them up, they look like they get further apart. Right, and I let them go, they get closer together. That's the hope, at least, so we're going to go okay with that. Wait for it to do its thing, build its thing down here and chug. Going to move it over here where it used to want to be. Hook it up. Okay, now I got the broken wire, which it's not happy with. There's you're stopped, right? Task out, stop, runs up to there, okay. And the stop runs up to here. Okay, so I've sort of replicated what I had, and now when I push run, it ought to run. I have values, right, that are sort of close to each other, right? It says it's 77 degrees in here, going down because I came off. I put my hand on it, it gets warm, right? Okay, and I let go, it goes back down again on some curve. So it certainly looks like it's working, right? We buy it working? Okay, looks like it's doing its thing. Okay, so I've got this thing all up there and working now, at least sort of. We can argue about which one I ought to be converting, because I think my interpolation one's probably a bit more accurate than my other one. we could take let's see, what do I ask you to do? So I know I gave you directions, right? Okay, so extend the LabVIEW program to directly interpret temperature from the provided data, right? Also create additional indicators on the front panel to display the interpolated temperatures and the difference between them and the fitted function temperatures. So you get to find what's the difference between the interpolated one and the,
Is there a way to display that? Like an indicator on your, to display the difference, or do you want like a written out? Okay, so on the thing, got it.
I think I want you to display the difference.
Yep,
So what do you mean? You want to calculate the difference?
no, I mean, you
Yes.
wanna figure it out on here, yeah,
Well, you want your computer to calculate the difference,
right.
right? Which I think you can do, right? That might involve arithmetic, right? Okay, so, and then you have to put another display up there, okay? So that's one of the things to do. Okay, now we're gonna do a linear correction, okay? That's because we're gonna calibrate this darn thing, okay? And we tend to calibrate these kinds of things, right? Because we're never quite sure how they're gonna go. We're never quite sure what the accuracy of the semiconductor devices is. We're never sure what the accuracy of our resistors is, or the accuracy of our DAC, or any of that sort of stuff. So what do? We calibrate them. And typically we do the easiest calibration to do is a linear calibration, where you're going, okay, basically a linear calibration, you calibrate it at 2 points, right? You say, hey, I'm gonna make it do with those 2 points. I'm going to get it to read values that I want, and I'm hoping that I have the shape of the function reasonably close, and that means that I'll be close on the rest of the ways. Now, what we're basically going to do in some sort of linear calibration, right, is we have a linear function, right? So we're gonna say that our value, right, our calibrated value is equal to what? This is gonna be equal to some m, and let's say y uncalibrated, plus b. Right? And what are m and our b are our calibration factors, right? They're things that we're going to have to enter to perform the calibration, right? So let's think a little about how we're going to do the calibration here, because there's times when it actually pays to think ahead just a little bit. Okay, so what are we gonna do to calibrate this thing? Well, we're gonna stick it in things that we know the temperature of,
Alright.
right? Right, it's like ice water and boiling water. Okay, so which one do we wanna start with? We'll probably start with ice water because it's easy, right? And what do we want to get it out of? We want it to go to 0. So, okay, what do? Initially, we're going to stick it in ice water, and we're going to have to set these values to something, right? Because if I leave these values at 0, what happens? I get 0 out, right? And so my calibration is, well, it tells me I'm at 0 degrees C, but in fact it tells me I'm always at 0, which is not particularly helpful. So this multiplier can't be 0, right? It's got to be, so let's say we start something like 1. Okay. So now we calibrate to 0. We stick it in ice water and it's not 0. So what do we change?
B.
Probably change the B value. So we put something in here, like saying we put in X, point X. Okay, some value in here. And then what do we do? Well, now it goes to 0, okay?
Yeah.
So we can do that, okay? And now then what do we do?
Stick in boiling water.
Stick it in boiling water. Okay, and now, okay, so we stick it in boiling water and then it doesn't read 100. So what do we change?
Change the M value.
We change the M value.
So that's a slope.
Right, so we make it some Z point Z, right? Some Z's, those are Z's. Okay, so we make some value in there, an M. And now, guess what? And it reads 100. But now we've changed what it was at 0. Because there was some value in here that was at 0, right? And now we've changed the multiplier in front of that. And so now we get to go back to ice water again, and we get to change that, and then it's not gonna read 100 anymore, and so we're going to iterate back and forth between these, right? And so you sit there, because I mean, you can see this coming, right? Because what we're doing is we're changing one and then the other, and we start looking at this and going, you know, this is foolish, and it is foolish. So, gee, that's kind of annoying. How do we get out of that?
Right, function.
Well, we've written a perfectly good function. Well, we've written a function, not a perfectly good function. But what's the problem? Well, the problem is that when we change the slope, the addition of those things isn't at 0 anymore. Well, let's just make it 0. Which is easy enough to do. We just do this. And now what does it do? Well, we put this to 1, and we put B to 0, and what do? We stick it in ice water and we adjust B until this is 0. Okay, and then we go stick it in boiling water and we adjust M until it gets to be 100. And then we stick it back in ice water and,
It should be 0.
well, this should still gonna be 0 because in order for it to be 0 true here, and M is not 0, this term has to go to
0.
0.
Right.
Right?
Okay.
Right? Now, is that a linear function? You didn't sound very confident there.
Yes, yes,
So
yes, yes,
you sounded more confident than those who didn't answer, right? Which is, but is it a linear function? Right? Well,
Yes.
yes.
is yes. Okay, why is it a linear function?
No idea.
Well, what's the requirement for it to be a linear function? Is that you can't have any weird function of x,
Right.
right? It can't be squared or
Exponential,
trig or exponential or something else, right? It's got to be linear in terms of x. Well, what happens if I multiply this through, right? This is equal to mx plus mb, right? Is that a linear function? Yeah, it's a perfectly fine linear function, right? In fact, it looks like all we've done is we've got this slope term being a little bit weird here, right? Right, it's not purely a y-intercept, but it did make our calibration process much easier, at least for this case, right? It doesn't always make your calibration easier, but sometimes it really pays to think about this. Now, how am I going to implement this? Well, you got to implement this one, right? What do? We take the value that's uncalibrated, we add b to it, right? And then so we're going to need to get those values from somewhere, and I'll sort of show you how to, I'll be nice and show you how to do that. Okay. I don't know why, but I guess I'm going to have to be nice here. So we're going to get some numeric
Thanks, Dr. B.
control, and I'm going to call this one slope. And then I'm going to get another control, numeric control, right? And we're going to call this the, intercept or slope or constant,
Like constant.
okay? Okay, so that's not exactly right, but close enough. So what do we do with it? Well, the first thing we're gonna do, how do I implement that expression up there? Well, it looks like, first of all, how do I do those parentheses?
Yeah, formula, right?
Nah, too much work. So what do we do with that? Well, you just, what are the parentheses determining?
Order of operations.
Order of operations. So all it's saying is the first operation is
Y plus B, or Y.
is an addition, right? So, okay, it's an addition. What do? I take the value and I add to it. Like that. And what did that give me? That gave me the term in the parentheses. Okay, and then what do?
Then you multiply that output.
I'm gonna multiply it, yeah. Okay, get out of here, what do I get? I get my final value, since I don't really wanna display the uncorrected one, I'm just gonna display the corrected one that I've compensated for. Okay. And if I wanna run that into my Fahrenheit, I can run it into my Fahrenheit thing here, right? Copy that all down here so I can tell which one's which, right? And I could even run the display one down here. Probably want to save the one that's actually calibrated, right? So. Right, and I think I'll even put the one on the chart that's calibrated. Okay. Now, that wasn't bad, was it? So you can do a little bit of math here, and actually, in some ways, this takes up less space than the formula block. Right, you certainly could correct, Brian, you could certainly do that in the formula block, but in some ways it takes up less space because the formula block, you're gonna have to have the constant, the slope terms anyway, right? So the only space that you took in doing the mathematics was the add and the multiply, right? So, now, could I have done the formula block that way instead of doing a formula block, multiply it by 1.8 and add 32? Yes, I certainly could have, right? It certainly could have, and it's not, you know, it's a matter of how excited I am about it at the time, right?
It's more style than function.
Absolutely, there's not a, okay. That's, yeah. Oh, okay, so we've done all the, let's see now, what else did I ask you to do? Then we get to go calibrate the darn thing, right? So we get to calibrate it. I had that written as scale and offset, but okay, well, that's the things. So we gotta calibrate the offset, we gotta do some multipliers, we gotta do screenshots of that. So I think we need temperature standards.